Hey, so this is a really good question. This was on my video critiquing the CDC for saying that folic acid is the same as natural folate for MTHFR. So let me show you why that isn't true, and let's talk about folinic acid. So you have to get folate into your cells, and you can do that one of a couple different ways. In the brain, you have FOLR1. You also have a protein. So the protein name is proton-coupled folate transporter, but the gene name, if you're looking at a gene report, is SLC46A1. And then you have the reduced folate carrier. The protein name is called reduced folate carrier. The gene name is called SLC19A1. They're confusing, I know. I'm trying to break it down and make it easier. In your placenta, you have mostly FOLR2. And then everywhere else you have mostly FOLR3, okay? And the FOLRs are also called folate receptor. FOLR1 is called folate receptor alpha. And again, that guy's mostly in your brain. So it's this job of these guys to get both the natural folates that you take from food and folic acid and push them into the cells. Now, FOLR1 and SLC19A1 do not like folic acid. It takes forever to get through the enzyme. And because folic acid is sitting in that transport site, while folic acid is taking its good old time, just sitting in there, the natural folates can't be in there and get transported. So while folic acid can get into the cell, it is not only slower, sorry, I've got a puppy. It's not only slower for it to get into the cell, it also prevents natural folates from getting into the cell quickly. So when we're talking about folic acid versus natural folates, we're really just talking about getting it into the cell, right? These enzymes function on something called substrate push. So I like to imagine this as one big assembly line, right? So if you have different people stationed at different points in the assembly line and you're trying to make wheels at the end, right? You've got one guy that gets the tube and puts it in the rubber outer coating. I don't know anything about wheels. And then that hands those two off to the next guy. He puts it on the metal rim, right? And then the last guy seals it and blows it up. If you have a delay in getting those first two parts, the wheel and the tube, the rubber and the tube, to the first guy, everybody after that's going to go slower. However, if every single time that guy has free hands and he hands that tube off, you hand him another rubber outside coating and tube so we can hand it off to the rim guy, then you're going to move that along at pretty much max capacity. And this is what's really important. Running this at max capacity is really important when you do have critical mutations in FOLR1, 2, SLC19A1, SLC46A1, or MTHFR. Because they're already slower due to gene mutations, we want to make sure that every single time they're available to do work, they've got the needed components right there to get that work done. Now, you were asking about folinic acid. So one of the big problems in coming through and getting folic acid into the cells is it has to go through DHFR. So not only is it slower getting into the folate transporters, it's also slow going through this DHFR. Folic acid and a lot of the natural folates have to get reduced before they can enter the folate cycle. And that takes a period of time, right? This is folinic acid. It's 5-formyl tetrahydrofolate. It doesn't have to go through DHFR, and it actually goes through the folate receptors and transporters pretty quickly. A lot of people choose to use folinic acid, especially as a high dose, to push the rest of this pathway over. And people like to choose folinic acid for two reasons. One, it doesn't have to go through DHFR, which is a big time saver, especially if you have DHFR mutations, which are pretty common in the population. And two, there's no methyl group here. There's none. This is a methyl group here. There's no methyl group right here. A lot of people, when you high dose them on a methylfolate, like this is 5-methyl-THF, they have really bad reactions. They can tolerate it to a certain point, or they may be able to tolerate it for a week or two, but once they get past that point and the bucket gets full, they start having kind of reactions where they get really anxious, really irritable, they feel like they're in flight or fight mode, and giving them folinic acid instead of methylfolate at high doses means that you can get them to a higher level, and the enzymes in between this will kind of regulate how much methylfolate that they have and prevent them from having a lot of symptoms of methyl trapping. Now, whether you're going to be able to tolerate folinic acid or not depends on if you can get it over here to the methylfolate, which is what you need to use, which is right here. So you've got to run it through MTHFS, and then MTHFD1, and then MTHFR. Now we can speed these enzymes up. Sometimes MTHFR is sped up by riboflavin, so vitamin B2. This guy runs on magnesium partially, and then this guy runs on NADPH, which is niacin derivative. So as long as these three are functional and you have the cofactors that they need, you should be able to get folinic acid right here, which is also called 5-formyl over to the guy you need to do the job. And you'll be able to do that without the risks of methyl trapping from giving them 5-MTHF. Now, can they do this? Can they make this jump? I don't know. You would have to check their genetics. And even in checking genetics, like I do, I check people's genetics every day of the week. And I will tell you that we don't know all of the gene sites yet. We know the big ones, and that's very helpful. But sometimes people have some weird mutations that just don't pop up. So sometimes we just have to try it and see if it works. I will tell you, this is a study that they did on sometimes you can have antibodies to that FOLR1, that folate receptor transporter in the brain that brings folate from your blood and pushes it into your brain for your brain to use for neurotransmitters and all kinds of other fun things that your brain needs. And having antibodies to this is actually correlated with drinking milk, like cow milk, camel milk, all kinds of different types of milk. So this study was looking to see if these people do have these antibodies that attack the folate receptor and prevent folate from getting into the brain and causing a worsening of symptoms of like anxiety and depression and ADHD and making their autism symptoms worse. What can we do to kind of like knock those antibodies off of the folate receptor and shove folate into the brain? And they found that you need a lot less. This is 5-methylfolate, so it's not folinic acid, but it will convert into folinic acid. You need a lot less folinic acid than you do folic acid. You need 8 times less. So when I go on these rants about hating folic acid, it is not from a space to where I want children to have neural tube defects. It is needed, unfortunately, in the food supply because it has decreased the rate of neural tube defects in babies. But I feel like if we did a better job in this country of educating mothers about the importance of methylfolate, especially if they have FOLR2 mutations, which I can give you the SNPs for those if you guys would like, then we wouldn't need it in the food supply. Or maybe we could put more folinic acid in the food supply instead of folic acid because it's obviously not working as well as kind of more of the natural folates. I would like to mention, so MTHFR is like right here. This is what MTHFR produces. It's 5-methyl tetrahydrofolate, okay? To use this, you need methylcobalamin, and that runs on its entirely own set of enzymes is to be able to make methylcobalamin. And you can also experience symptoms of methyl trapping when you take methylcobalamin as well. And it also needs zinc. So I always tell everybody, if you touch one single thing in any biochemical, in any metabolic pathway, you're going to probably touch like 10 other things. So would I take folinic acid instead of methylfolate? Absolutely. Would I feel comfortable trialing a very, very small dose of folinic acid with my children? I would. I would probably start at like 1/10 of the pediatric dose and slowly increase it just to see how they do. I would let their teachers know. I would get prior clearance from their physician because, again, we don't do anything without their pediatrician signing off on it. But do I think that it could be extremely beneficial, especially partnered with B12 in children with anxiety, depression, ADHD, autism? It could be. I don't know, because even if I had every child's genetics, we're still kind of guessing at this because the science is very new. Genetics gives me a fantastic idea. And we can make a lot better of an educated guess with genetics. But that's why people prefer folinic acid over like this. It's because it's got less of a risk of a reaction and it's closer to the like good enzymes that you need to do the job. but it's past DHFR, so it's a little bit easier just for your body to work with.